This slide introduces the session's core focus: generative AI and prompt engineering. Explain that generative AI (GenAI) refers to AI systems capable of creating new content such as text, images, code, audio, and more. Highlight that the goal is to understand large language models (LLMs), how they work, what they can do, and how they can be used effectively. Emphasize that a major part of working with AI is prompt engineering, the skill of designing clear, structured prompts that produce accurate, creative, and useful AI outputs. Mention the objective listed on the slide. To master the fundamentals of generative AI, understand how LLMs operate, and learn to design effective prompts that enhance creativity, automation, and productivity. Let the audience know that by the end of the session, they will have practical knowledge they can apply in real scenarios, whether for work, projects, or problem-solving tasks. This slide introduces the fundamental concept of generative AI, often referred to as GenAI. Explain that GenAI models are capable of creating new content such as text, images, music, video, or even code by learning patterns from large amounts of existing data. Highlight a key difference. Traditional AI generally classifies or predicts based on input data. Generative AI, on the other hand, produces new outputs that didn't exist before. Walk the audience through the examples provided under content explanation. Text generation: models like GPT, Claude, Gemini, and Llama can write articles, answer questions, generate scripts, and more. Image generation: tools such as DALL-E, Midjourney, and Stable Diffusion can create original illustrations, designs, or photorealistic images from text prompts. Music and video: technologies like Jukebox and Sora generate songs, soundtracks, animations, and even cinematic videos. This slide highlights key applications of generative AI, such as content creation, design ideation, summarization, software development, and marketing personalization. Emphasize how GenAI speeds up creativity and improves efficiency across industries. Mention the real-world example. Coca-Cola used tools like DALL-E and GPT in their global Create Real Magic campaign, showing how major brands leverage GenAI for large-scale creative projects. This slide gives an overview of major large language models (LLMs) and what makes each one unique. Explain that LLMs are trained on huge text datasets to understand and generate human-like language. Highlight the four popular families: GPT, OpenAI, strong in general reasoning and multi-domain tasks. Claude, Anthropic, known for safety, context handling, and ethical alignment. Gemini, Google, excels in multimodal abilities: text, images, and video. Llama, Meta, lightweight, open source, and highly adaptable. Wrap up by noting that these models power many AI applications we use today. This slide explains key concepts behind how LLMs work. Parameters: billions of learned weights that help the model understand patterns. Tokenization: text is broken into small units so the model can process it efficiently. Context window: the amount of information the model can keep in mind during a conversation. Zero shot: few-shot learning: the model can perform tasks with no examples or just a few examples in the prompt. The real-world cases show practical use. Shopify uses GPT-Apis to generate product descriptions and support customers. Meta open-sourced Llama to enable academic and enterprise innovation. This slide explains the three main types of generative outputs: text, images, and code. Text generation: LLMs use transformers to predict the next word used for chatbots, content creation, and reports. Image generation: diffusion models add and remove noise to create images used in ads, product design, and art. Code generation: models like Copilot or Codex assist developers by generating or completing code. Summarize with the workflow. You provide a prompt to the model, processes it produces structured or creative output. This slide shows practical examples of what generative models can do with text, images, and code. Text example: generating marketing emails or written content instantly. Image example: creating product visuals like a smartwatch using diffusion models. Code example: generating useful functions such as a Python script to calculate ROI. The real cases highlight how image and code generation are used in fields like product design, advertising, and software development. This slide explains what prompt engineering is: creating clear, structured instructions so AI produces better results. Highlight the 5 core principles: clarity, avoid vague or ambiguous wording. Context, add background, tone, format, and examples. Constraints, set limits like style, length, or structure. Role assignment, ask the AI to act as a specific expert or persona. Iteration, refine your prompt based on the model's output. Emphasize that good prompts lead to more accurate and useful AI responses. This slide shows how a vague prompt can be improved with clarity, context, and constraints. Instead of simply saying "write about AI," the refined prompt gives a role, length, audience, and purpose, leading to a much stronger output. The real case from HubSpot shows how companies use structured prompts to create personalized blog content and sales scripts efficiently. This slide covers advanced prompt techniques that help get more accurate and consistent results from LLMs. Prompt chaining: break a complex task into smaller steps for better clarity and control. Role play: assign the AI an expert persona to improve contextual thinking. Context management: use summaries or key points to help the model remember long conversations. Few-shot prompting: provide examples so the model understands the expected format and tone. Emphasize that these advanced techniques significantly enhance model performance in real-world tasks. This slide demonstrates how advanced prompting works using a real example. The prompt assigns a role, a Six Sigma consultant, and breaks the task into 3 clear steps: analyze, suggest improvements, and create a summary. This shows prompt chaining and role play in action. The real case highlights that EY Consulting uses these techniques to automate parts of their internal audit report process, improving speed and consistency. This slide explains fine-tuning, which means retraining an existing LLM with domain-specific data so it performs better in specialized tasks. Cover the 3 main approaches: instruction tuning, training on question-answer pairs to improve task following. RAG, combining the LLM with a knowledge base for more accurate, fact-based answers. LoRa, a lightweight tuning method that requires minimal computing power. Benefits include much higher accuracy in niche fields like law, healthcare, or compliance. Ensures the AI's tone and style align with a company's brand or policies. This slide highlights tools commonly used for fine-tuning LLMs, such as the OpenAI Fine-Tuning API, Hugging Face Transformers, and vector databases like Pinecone and Chroma. It also shows real examples. PwC uses a fine-tuned GPT model for internal compliance documentation, and AIG could fine-tune GPT on ISO and lean content to support consultants. Key message: fine-tuning enables organizations to tailor models to their domain and improve accuracy for specialized tasks. This slide highlights that generative AI can unintentionally reproduce or worsen bias from its training data. Emphasize the importance of ethical AI practices to ensure fairness, responsible usage, and protection of sensitive or unauthorized data. Key focus areas include monitoring bias in generated outputs, using clean and authorized data, and crafting unbiased prompts. This slide covers key steps for ensuring ethical and unbiased use of generative AI. Highlight practices such as human-in-loop review, neutralizing biased prompts, and using bias testing tools. Mention the importance of transparency through model cards. Real case, Google Gemini paused image generation due to diversity bias issues, showing responsible AI governance. This slide highlights how Gemini supports marketing, product design, and knowledge management. In marketing, AI helps create personalized content at scale such as ad copy and visuals. For product design, it accelerates idea generation and prototyping. In knowledge management, AI provides instant summaries and insights from large text sources. Key point: Gemini acts as a creative partner, enhancing human creativity rather than replacing it. Real examples include tools like Adobe Firefly for design and Notion AI for content summarization. This slide shows key platforms and AP is used to integrate generative AI into business systems. Categories include text, images, code, frameworks, and deployment, each with common tools like OpenAI API, Stable Diffusion, Langkine, and Streamlit. Example integration: building an internal knowledge bot using GPT with SharePoint and Teams. Real-world use cases include HubSpot AI Hub and Salesforce Einstein GPT. If you want them even shorter or more formal, I can refine further. This module wraps up the course with a capstone project where learners build a custom AI assistant tailored to a specific domain. The goal is to apply everything learned: prompt design, API integration, retrieval, and ethical considerations. Example project ideas include an AI marketing assistant for generating campaign content, a knowledge bot for ISO standards using Retrieval plus GPT to answer audit questions, a creative designer assistant using DALL-E and GPT for concept ideation. Deliverables include a designed prompt workflow model, API configuration, sample interaction logs, a business case analyzing raw risks, and scalability.